Module 10, Experiment 10.1, Carbon dioxide and the greenhouse effect.
In this experiment, we're going to take a look at how carbon dioxide absorbs energy from the sun. And so we're going to run actually two portions of the experiment, one with air and one with carbon dioxide. So the first part of the lab is going to involve taking a zip top bag like this, and you want to just kind of get some air in it. So flip it upside down and move it around to catch some air inside. Then you want to take your thermometer, set it inside of this bag, and zip it closed. So now you have a little pillow of air with a thermometer in it. And you want to set this inside of a window. So you're going to set your pillow of air in a sunny windowsill, just like this, and orient it so that you're able to see the thermometer readings without removing the thermometer out of the bag. After 15 minutes, take a reading of what the temperature is on the thermometer, and then record that in your lab notebook, and we'll be ready for step 2. Well, for the next part of the experiment, we're going to take our Ziploc bag and we want to fill it with carbon dioxide. So first thing I'm going to do is remove my thermometer, set it aside, and I'm going to get rid of as much of the air as possible from the bag. So now I have an empty bag. And I need to create carbon dioxide. So in order to do that, I have an empty 2-liter bottle. I'm going to fill it about 1/3 of the way with vinegar. This is just white vinegar. All right. And now I'm going to add some baking soda. When vinegar and baking soda react, the gas that they produce is carbon dioxide. So I'm going to take about a teaspoon of that baking soda. And you see it's getting nice and bubbly. That gas is carbon dioxide, and what it's doing is it's pushing the air up and out. So right now my bottle is filling up with a little bit of carbon dioxide. I want to make sure that I get all of the air out though, so I'm going to add another teaspoon. Push the rest of that air out. Let it react. Okay, and then once this is done reacting, the tricky part comes in. We want to, now most of the air, if not all of the air, is out of my bottle. This is just carbon dioxide that's sitting in my bottle. But I want to create some more carbon dioxide and collect it. So I'm going to do this one more time with the teaspoon of baking soda. But this time I'm going to work very quickly and put my bag over the top to try to collect the carbon dioxide that it's producing. So you got to work really quickly here. A good scoop here. And one hand here, one hand here. And there we go. I'm putting my hand around the bottle to try to capture as much carbon dioxide as possible. You can see my bag just moving, filling up a little bit. It's not going to fill up like a balloon, so don't worry about that, but just make sure you try not to let any of the gas out of the bag. And once it's done reacting, just carefully zip it closed. Now we want to set our thermometer inside the bag, so I'm going to open it just a little bit, slide my thermometer in, close it back up, and again, we go to the sunny window. We're going to now set the bag in the sunny window, and again, orient the thermometer so that you can read the thermometer without handling it, and then let it sit for 15 minutes. At that point, take your temperature reading, record that in your lab notebook, and then we'll talk about the results that you get. So now you have your two temperature readings, one with air and one with carbon dioxide. You should notice that the temperature reading with carbon dioxide should be higher, and that's because carbon dioxide gas absorbs sunlight energy. It absorbs energy much better and more efficiently than air does. Air does have a component of carbon dioxide in it, but it's not pure carbon dioxide. So you should learn from this lab that carbon dioxide is a great absorber of sunlight energy.
In the experiment, you should have observed that the bag containing carbon dioxide had a higher temperature than the bag containing air. Carbon dioxide absorbs solar energy, so the more carbon dioxide present, the warmer the temperature. Of course, if there is less carbon dioxide present, then the temperature will be cooler. Carbon dioxide is one of the main greenhouse gases, helping to keep the Earth at a constantly warm temperature. If its levels increase in the atmosphere, the warmer our planet will become. And if it got too warm, the stores of ice at the Earth's poles would melt, flooding much of the world and drastically affecting life. If its levels decrease in the atmosphere, the cooler our planet will become. And if it got too cold, much of the planet would be uninhabitable. So it's important that the carbon dioxide amounts are carefully regulated. Some people are worried that the carbon dioxide levels in our atmosphere are changing too much. They believe it's due to the effects of modern society, with countries burning more coal, oil, and other fuels as industries grow. And as you look at the carbon dioxide levels in the past 100 years, it's evident that carbon dioxide levels have indeed been rising. So if we keep adding excess carbon dioxide into the atmosphere, are the Earth's temperatures also going to rise too much? This is the concern about a phenomenon called global warming. Some people are very concerned about our emissions of carbon dioxide into the atmosphere and believe they should be controlled, or global temperatures will rise and affect living things. Now, of course, if too much carbon dioxide were to build up in our atmosphere, it would absorb more solar energy, resulting in warmer temperatures. But there's a lot more going on than the information I just discussed. Take a look at this graph. It tracks the amount of carbon dioxide in the atmosphere over many years. The concentration of carbon dioxide is measured in parts per million. This data represents the largest collected set of data that focuses on carbon dioxide in our atmosphere. The data collected between 1900 and the 1950s is mostly estimated and extrapolated from points of data taken during that time. Now I'm going to add this diagram to the timeline. It plots the change in global temperature each year. So the zero line means that there was no change in a particular year, and it also represents the average global temperature of approximately 10 degrees Celsius or 50 degrees Fahrenheit. If the data is above the zero line, there was an increase in global temperature, and if the data is below the line, there was a decrease in global temperature. We have data going back as far as 1880, but you need to know that the temperature data taken from that time up till 1978 were from measurements taken on the ground. You may already know that nearly 71% of our Earth is covered in water, so the temperature readings taken on land are not completely accurate global temperature measurements. After 1978, temperature measurements were taken from satellites. Because of their vantage point, satellites could measure the temperature of the entire Earth, oceans and all. So look at the two graphs again. Notice that the graph on top shows us that carbon dioxide levels in the atmosphere have been increasing steadily since about 1920. But has the Earth's average temperature been increasing from that time? No, it hasn't. From the year 1880 until about 1920, the average global temperature bounced up and down by about half a degree Celsius. Then, after 1920, the temperature continues to bounce around, but it averages at the zero mark of no overall change. By looking at these two graphs together, we can see that though carbon dioxide levels have increased a little, the average temperature of the globe has not really been affected. So, can we say that carbon dioxide levels do not affect the temperature of the Earth? No. There is such a phenomenon as the greenhouse effect, and thankfully there is, or we would not be able to live here. So there must be more to the story. For carbon dioxide to increase global temperatures, there has to be a significant increase in carbon dioxide levels. But we don't know what a significant amount is. What we do know is that human activity on Earth is responsible for only about 3% of the processes that add to the carbon dioxide in the air. So we may not be producing a significant amount to affect the Earth's temperatures. And it's important how our carbon dioxide production is being added to the air too. When we burn fuels, we are not only producing carbon dioxide gases, but other gases too. And these gases tend to reflect light, not absorb it. This could mean that the heat absorption of the carbon dioxide released is canceled out by the reflective features of the other gases that are released. Well, what we can definitely say is that looking at the reliable data, the Earth does not seem to be warming, at least significantly. We can say something else too. There is data that show the Earth has been much warmer in history. Scientists have studied information on historical global temperatures and have found that the Earth was significantly warmer than it is today between 800 AD and 1300 AD. And we know that during those times there was not the significant burning of fuels we see today. So it's believable to say that the modern burning of fuels is likely not leading to global warming. Therefore, if the data is indicating that global warming is not occurring today, and scientists have shown that the Earth has been much warmer in the past, why do we hear so much about global warming? Well, one reason may be due to the fact that people who discuss the ecosystems of the Earth do not really understand them from a scientific standpoint. They tend to use their personal experiences instead. After a particularly warm winter, people may begin to use that as proof of global warming, when we know that they are just observing a local temperature event. Often, when one part of the world is experiencing warmer than normal temperatures, another part of the world is experiencing cooler than normal temperatures, so the overall global temperature is not different. You may have also heard reports that the ice sheets in the Antarctic are melting as a result of global warming. Well, if you look at the actual data, you will see that indeed one large ice peninsula in Antarctica is drastically melting. But there's also data that show that on the other side of the Antarctic continent, the ice sheet there is thickening. So while one place in the world is getting warmer, another place in the world is getting cooler. In fact, when scientists take overall temperatures of the Antarctic continent, they find that the average temperatures have been getting cooler during the last 50 years. Is this support for global cooling? No. To determine that, you would have to look at overall temperatures throughout the entire Earth. And remember, when some people point to some data that show the Earth is warming, they are focusing on the land-based temperature measurements only, but they do not consider the other 70% of the world, the temperatures over the oceans. When you look at all the available data, and particularly the most reliable data such as satellite measurements, it's clear that at the present time, global warming doesn't appear to be occurring.